to on page 124. So I'm a creature of habit, so I start the process the same every time. So I identify first, what am I supposed to achieve in this problem? So this says, what mass? So that's my end point. And on our stoichiometric diagram, the right-hand side is always the end. So that means I am ending here in the most right-hand mass. Well, this mass belongs to the precipitate. So I'm going to put down PPT. And it says that the precipitate is produced. So that means, so abbreviation precipitate means that it's one of the products in the reaction. So it is a product because it's produced. That means it's a product. And that means also, because it's a precipitate, that means that its phase is going to be a solid. So when I take a look, products are over here on the right-hand side. So this is a product. And I have to look at the phases. And when I look, the phases are not given. So I have to figure out the phases. So in order to do that, you will have to use your table F. Worry about that in a minute. Let's figure out what else is provided for us. So as I'm reading through, I see 245.5 grams, which is another mass value, and I'm told it belongs to barium chloride, BaCl2. And when I take a look in the reaction, BaCl2, it's to the left of the arrow, which is the reactant side, which you already know that. So BaCl2 is not the precipitate, it's something else. So I know I need some information about BaCl2. So that means this is where I'm going to start with that 245.5 mass, and that belongs to the barium chloride. So to get all the way from the mass of barium chloride, one of the reactants, to the mass of the precipitate, which is one of these two products, I'm going to figure out my pathway. So I have to go from the mass of barium chloride. The only thing I can change it into would be moles of the barium chloride. Once when I know the moles of barium chloride, I can then change that into the moles of the substance of interest, which is the precipitate. I don't know which one's the precipitate yet. And then I've got to get to the mass of the precipitate. So I can just kind of get some general stuff done here and getting myself set up. So I'm going to start off with my mass of 245.5 grams of barium chloride. And the only thing I can change that into would be moles of barium chloride. And I want to be able to cancel out grams of the barium chloride. Well, next thing is, once when I am here in the moles of barium chloride, I want to get to moles of the precipitate. So I'm just getting myself set up. So I'm going to put moles, and I want of precipitate. So I guess up here, just a little note I'm going to write, I need to know something about the PPT, right? I need to know which of the two products up there is it. And I'm coming away from moles of the barium chloride. So moles of barium chloride will be gone. And then from here, I know that I need to get to the grams of whatever the precipitate identity is. And I need to come away from the moles of that precipitate. And I'll fill in the actual chemical formula once when I figure out which product is the precipitate. So let's do that now so we can figure out some stuff. So here we go. The table F, okay? So our first product is AgCl. Cl. So I'm going to switch over to my table F. What you need to do, as a reminder, is you need to find one of the partners in the compound. So my compound right now is AgCl is the first one, okay? So Ag, do I see it in the highlighted blue column of the first little table? I do not see it. So then I move over to the other blue highlighted column. Do I find Ag there? I don't. So that means I need to find Cl in one of the blue columns. So I'm looking down this one. Oops, here is the Cl. So here's the thing. Cl, because it's in this first column, it dissolves. So I'm just going to write dissolve. Now I have to look at the partner. So because Cl is in this column, it forms typically soluble compounds. It dissolves. Now I have to look at the exceptions, and I have to see whatever Cl is bonded to, is it one of the exceptions? Well, it's bonded to Ag, and look at right here's Ag. So this is an exception that makes Cl not dissolve. So chlorides typically dissolve, but this is one of those exceptions when it doesn't. So AgCl is an example of a precipitate. So if I go back to my page 124, okay, so this is a precipitate, so therefore its phase is solid. Now I'm just going to do some check-throughs to make sure I use table F correctly. So my other product is the barium nitrate. So when I come back over here, I have BaNO3 2. So just like before, my first partner is Ba. I don't see it in the first column. I don't see it in the other blue column. So I can't tell based on Ba. So I'm going to look for my other partner, NO3, what is in the parentheses. And when I look here, in this first blue column, oh, there's NO3. So NO3, it typically dissolves. Now, I have to take a look at the other partner, Ba. So when I take a look at NO3 and I look at the exceptions list, there are no exceptions. So Ba, it's not an exception. So it's not an exception to prevent NO3 from dissolving. So BaNO3, NO3s form soluble compounds. Ba is not an exception. So BaNO3 is not a precipitate. As it forms in the reaction, it will remain aqueous. So the identity of my PPT I have just figured out. So let's get that information written down. So the PPT here, it is AgCl. So wherever, so I need to know information about the AgCl. So wherever I noted PPT in my math, I'm going to put in that formula AgCl. Now I can continue on with my math. So take a look. To go from mass to mole of the same substance, that means I need GFM information. So 1 mole of barium chloride is equal to the GFM of barium chloride. So barium chloride, figuring out its GFM. 1 barium supplies 137.3 plus 2 chlorines, each supply 35.5. So the GFM of barium chloride is 208.3 grams. So there's my relationship. So for every 1 mole of barium chloride, the mass will be 208.3 grams. Now, for this next reaction, my unit or quantity moles is the same, but it's different identities, so that's the balanced reaction. So I have to go to the reaction, and when I take a look at it, it is not balanced. So I notice right away That on the left I have 2 chlorines, but only 1 on the right. So I'm going to fix that super quick by putting a coefficient of 2 in front of AgCl. When I do that, it makes my chlorine count match left to right, but now my Ag count doesn't. So now I have 2 Ags on the right. Come over, left only shows 1, so I'm going to put in a coefficient of 2 in front of AgNO3. Now my Ag count is okay. This coefficient makes me have 2 units of the poly, NO3, but when I look over on the right-hand side, the poly has a subscript of 2, so I have 2 units of that poly. So I understand these 2 formulas, their coefficients are 1. So now I have my coefficient information for the reaction. So here we go. So for every 2 moles of AgCl produced in the reaction, 1 mole of barium chloride is required. So now I am here mathematically. Now I need to plug in my last information, going from moles of the precipitate to the mass of the precipitate. So this is a GFM problem. So here we go. So 1 mole of AgCl is equal to the GFM of AgCl. I just need to figure it out. So there's 1 Ag atom, its mass contributes 107.9, plus the only Cl, which is 35.5. So the GFM of AgCl is 143.4 grams. So here's my relationship. For every 1 mole of the precipitate, silver chloride, AgCl, forms 143.4 grams of that substance. So now I can simply pick up my calculator and calculate the number of grams of AgCl. So when I put this into my calculator, I didn't leave myself a lot of room here to write the answer. My final answer would be 338.0 grams of AgCl. So your job is to try the practice questions on page 125, and we need to make a little bit of an adjustment. I've got a typo at the bottom. So last question, we need to change these from moles to grams so that you can actually solve the question. So response A will be 32.0 grams. Response B, 40.0 grams. Response C, 16.0 grams. And response D, 20.0 grams. Try these multiple choice questions. Check your answer with the teacher. And then carry on to page 126. You do problems. Some of the problems, mass to mole, or it could where you require 2 equivalences, or it could be mass to mass where you need 3 equivalences. Show the correct numerical setup as dimensional analysis.